clear for you, and I'm showing you examples of the diastereotopic protons. Basically, these are the protons which are non-equivalent, and they show different signals. The fact is that I am providing example. For example, this very compound, where it is very visible that this proton is different from this proton, and this is proton also here. So I am coding here there are 3 signals. Now these protons are same, they must show one signal, but they are not same because they are diastereotopics, and this can be tested by replacement. So whenever either C or B proton out of one is replaced, like C is here replaced by D, a higher isotope of the H, which is diastereotopic proton, which is actually deuterium, sorry. And when the same B proton is placed, we get this type of enantiomer, and we find that while rotating by using our system, this shows configuration of S, and this carbon it shows configuration of, we can say, R. So this carbon and this carbon, they differ in terms of their R and S configuration. That means the protons are different, and such protons which are different here, they are diastereomers. In these protons, the first half is non-superimposable and the second half is superimposable. They are acting like a diastereomer, and they are not the mirror images, and they are also not identical, but however they are stereoisomer, and hence they are called diastereomers. Now quoting another example which is very easier, like I have taken here alkene, in which I quoted again 3 signals A, B and C. First I replace the one which is here, that's B proton by D, and in second case I replace another proton which is noted by here by D. Looking at these two again are isomers, but basically the two are not neither identical, and they are diastereomers because the first half is superimposable and the second half is non-superimposable. They are not mirror image at all, so they are diastereomers actually. So these protons are said to be diastereomeric, and these protons are diastereomeric. That means they are non-equivalent. Now come to another example where I have taken this system. It's a chiral carbon, and this is a chiral carbon. So when I turn this chiral carbon to chiral carbon by replacing one of the proton, either HA or HB, by deuterium, and I find that this lowest this is actually out of the plane system D proton, and this is the system which is consisting of D proton here, deuterium. So finally in the two systems you again find that this is S and this is R system. So in nutshell, the diastereomers are neither identical nor mirror images. They are non-equivalent, they show different signals, and these 3 examples I am again quoting here, they are diastereomers. Now 2 protons of B and C first example are same, no 2 protons of second A and B are same, and no 2 protons of H, A and H are same, which seems to be very same, but they are not same because of this a chiral system convert to chiral, and when this chiral system of the 2 enantiomers are there, which are not enantiomers but which are diastereomers here, because they are non-mirror images and they are actually non-superimposable, but then one half is superimposed on other and one half is not superimposed on other. This is called we can say diastereotopic proton.